Hey everyone. So the starting point for this talk is that reading is essential for nearly practically all aspects of our modern life. From very mundane tasks, such as our ability to find parking on the way here and not getting our car towed, to social skills, such as our ability to keep up on what is actually going on in the world, to crucial daily tasks, such as our ability to take a medicine correctly. If we cannot read, we cannot do any of those tasks efficiently. Unfortunately, however, we don't think about the fact that not all of us actually can read efficiently. There's very convincing large-scale data from the OECD, the Organization of Developed Nations, that tell us that 1 out of 5 individuals fail to read efficiently, even in adulthood. That is, these are people who have problems understanding even short and relatively simple texts. This number, by the way, is even higher here in Israel, where it is estimated 1 out of 4 individuals have similar issues. So driven by this quite overwhelming statistic, in my lab we ask 2 big questions. The first is, why is this the case? That is, what determines whether someone is going to have problems reading. And the second is, if we actually understand what determines this variability, we want to understand, well, what can be done about it? How can we improve the lives of people that struggle to read? Now, the way that we actually go about this, to answer these big questions, we try to get a fresh perspective on reading, trying to investigate it as a process of pattern learning. Sometimes in my lab, we use the term trying to understand reading as an exercise in a broader phenomena, cognitive phenomena, that is sometimes labeled as statistical learning, which is defined as our ability to pick up on patterns and regularities in our environment without necessarily trying. Now, I know that this sounds a little bit fancy and perhaps abstract. So in order to actually exemplify what do I mean by that, I want to run a short demonstration with you, okay? So I'm simply going, and I'm really hoping that it's going to work. It works in like 80% of the time, so pardon me if it doesn't. So I'm going to present a sequence of letters on the screen in English. This is a sequence of letters that has no meaning. It's not a real word. And I simply want you to not overthink it. Simply read it aloud, okay? Simply say aloud what this sequences, how those sequences should sound, okay? You ready? 1, 2, 3. Okay, I'm foreseeing problems already. Okay, let's do another one, okay? Ready? 1, 2, 3. Okay, great. Okay, so we had 2 sequences here, right? So the second one, I think that there was a consensus, right? The second one, C-H-E-A-M, this was always read as Chim, exactly. The first one, right? Many of you have read it as Chid. Some of you have read it as Ched, exactly. Okay. Why is that? Why does this differential behavior? By the way, when I do this demonstration with native English speakers, the vast majority of them reads the first one as Ched. So why is that? What happens here? What determines this differential behavior? What this actually exemplifies the fact that readers are sensitive to subtle patterns and subtle regularities that exist out there in how letters probabilistically represent sounds. In this particular case, the fact that the sequence of letters E-A before M is always in the language being read as E, but E-A before the letter D is often being read as M. This is just one example. There are other probabilistic patterns. Written patterns also probabilistically represent meaning. So for example, words such as farmer, trader, and fighter all have something similar in how they are written, as well as in their meaning. But this is again a complex system, so corner is not someone who corns, right? Now, these very simple examples exemplify a key idea that governs a lot of my research, actually, which is that learning to read involves detecting patterns and regularities, often complex ones, that exist in our writing systems. Concretely, in the most basic levels, knowing how to read entails knowing to associate the printed units of the language, let's say the sequence of letters C-80, with the sounds that those sequences represent, in this particular case, the sequence of sounds cat, as well as with the meanings that those sequences represent, in this particular case, this object in the world, the object of cat, right? Now, importantly, the mapping between print, speech, and meaning is not arbitrary, right? It can be characterized as a complex system, probabilistic system. And there are patterns in the mapping between print, speech, and meaning that if we actually pick up on them, we can read more efficiently. Now, in order to actually understand readers' behavior from this perspective of pattern learning, to investigate reading as this statistical learning process, we go in 2 complementary lines of research, essentially. On the one hand, we try to quantify the input. That is trying to mathematically quantify what are those different patterns, giving numbers to different patterns that exist out there. In writing systems, this is a work done primarily by a group of computational linguists. These are linguists that have some background as well in computer science as well. On the other side, we try to examine the output. That is understanding how those patterns impact behavior. And this can be different types of behavior. This can be simple reading tasks, such as the one that I showed you before, the demonstration. This is something that we do mostly with kids. But it can also be text reading and sentence reading. And then we also use eye tracking technology to actually look at where people's gaze is at every point in time. Right? And this is work done primarily by a group of cognitive psychologists and cognitive scientists. Now, importantly, it is essentially the combination between those two worlds that enable us to understand reading as a pattern learning phenomenon. Essentially, the idea is that combining those two worlds, understanding the structure of the input and understanding how it impacts the output of different readers, can help us characterize readers in terms of the different patterns that they are or are not sensitive to. So let me just show you a more concrete example. And I want to tell you a little bit about a study that we've recently ran. Okay? This is a study done a couple of years ago. So it's actually a very simple study. So we had 399 early readers. This is children in early elementary school years. And all of them read a list of 160 words. Right? Now, importantly, we didn't just select those items randomly. We didn't just select those words randomly. We selected them so they actually vary in two critical dimensions. The first, perhaps unsurprisingly, is how regular different words are in terms of the mapping between print and speech, right? Print, sound, regularity. This is something that, again, can be quantified mathematically, continuously, but generally speaking, words such as street and mint are regular in terms of print to sound, because the letters E, for example, in street, are always being read as E, and the I in mint is typically being read as in mint. Words such as wash and child are irregular, right? Because I is not typically pronounced as I, as in the word child. Same for A in wash. Okay. And if you think back of this triangle example, right, this triangle notion, the idea is that print speech regularity has to do with the mapping, with someone's knowledge of the mapping of how printed units of the language map into the spoken units of the language. The second dimension that we manipulated is called imageability. And this is essentially defined as the ease of eliciting a mental image of a given word. So words such as dog or child is very imageable. It is easy to imagine a dog, right? It is harder to imagine verb or hope, okay? It's not that concrete. It's a more abstract term. And if you think back of the triangle, this essentially is a factor that has to do with the meaning, with some semantic influences that has to do with the meaning of the word. But importantly, this actually doesn't have to do with the mapping between print, sound, and meaning. If someone relies on how imageable a word is in order to read, this is not something that has to do with the actual knowledge of the statistical patterns of the language. This is an arbitrary cue. Now, importantly, given that we had this variation in our design, in our words, we could now examine for each individual how sensitive they are to those two dimensions, right? So here, for example, you have a kid who is impacted strongly by sensitivity, by print speech regularities. This is a person who is sensitive to print speech regularity. Operationally, practically, it means that this person reads correctly, in a higher probability, reads correctly words that are more regular in terms of the mapping between print and sound, and reads incorrectly words that are irregular. But this person, on the y-axis, this person is not sensitive to imageability. Whether a word is imageable or not, it doesn't impact whether they are going to read the word correctly or not. This, however, is a person that is very much impacted by imageability. That is, they have a higher and higher chance reading a word correctly as the word gets more and more imageable, but they are not impacted by print speech regularity. If a word is regular or not, it doesn't impact their behavior. And we do this for each of our 399 kids. Okay? Now, the next step is to look at whether those two dimensions that actually reflect sensitivity to different patterns and cues in the writing system is going to impact reading skills, right? Does it have any relation with the outcome that we care about reading skills? And the answer is a clear yes. So if you simply, to show you the data, I'm simply going to add colors to this plot, this figure. So kids with higher word reading skills, as reflected in standardized word reading measures, such as the ones that we typically do in schools, are going to have a red color. Kids that have lower reading skills are going to have a bluer color. Okay? And this is the data that we have, right? So this is a case, it's relatively rare in social sciences, where you don't really need statistics because the data really stands out. Essentially, there's a very clear link between those two dimensions and reading skills, such that readers that are more sensitive to print speech regularities and are less sensitive to this arbitrary, inefficient semantic cue, imageability, are the best readers. In addition, in a follow-up work, we have also shown that those two dimensions predict not just reading skills at a given time point, they can also predict ahead of time, prospectively, whether someone among individuals who have reading disabilities is going to react well to an intervention. Right? They can predict reading gains as a result of an intervention among individuals with reading disabilities. So together, those two studies essentially show that sensitivity to different patterns and different quasi-regularities in our environment are strongly predictive of the state of someone's reading system, both at a given time point and also prospectively. So just to sum up in a simple take-home message, I do believe that by applying cognitive theories of learning, we can understand better why some can and cannot read, essentially tracing back the variability that we know exists between individuals to their ability to pick up on patterns and regularities from the environment. And importantly, this is not just this hypothetical academic question. By understanding those sources of variability, we want to now do something about it. So what we now try to do is essentially devise individuated learning programs that target patterns that a given individual has problems assimilating. And the vision is that essentially every reader is going to get a curriculum that best fits their cognitive abilities and their cognitive needs. Thank you for your time and attention.
Thank you, Noam. Questions?
Hi, thank you for the very nice presentation. So I was wondering, how much is this related with the native language of the person who's reading? And how much like learning a different language can help in this sense?
Yeah, that's a wonderful question. So asking how, to what extent those findings and this perspective has to do with different languages that people speak? Yeah, that's a great question. So what I like about the question of cross-linguistic differences is actually that from our perspective, it can be thought of essentially as this natural statistical learning or pattern learning experiment. So the idea is that different writing systems are different from one another in what type of cues and regularities are beneficial for reading in a given language. So for example, in a writing system like Spanish, where the mapping between print and sound is very, very transparent, right? I don't know the meaning of words in Spanish, but I can read Spanish fluently just because everything is so easy to read, right? This particular cue is very, very efficient. In a language such as Hebrew, it can be way less efficient. So in that sense, the sensitivity to the same pattern can be beneficial in one language, but detrimental in another. And we have work looking specifically in that. It's in early stages, but these are exactly the type of questions that we ask. Thank you.
I had the same question.
Oh, I can answer it again.
Hi, Noam. Thank you for the wonderful talk. I'm Eran from Hebrew University. I'm wondering if those best readers from the lower right quadrant in the graph are also predicted to be better in understanding a whole text, not just single words.
That's a great question. So the answer is yes. For this specific sample, we also have standardized measures, not just at the single word level, but also passage comprehension and reading fluency, and the answer is yes. It generalizes across different reading tasks. I do think that a part of the question has to do with the developmental trajectory, right? We are here dealing with very early readers, where essentially most of what they try to do is read individual words, and this is where most of the variance exists. When we now go into older and older and older readers, then the picture changes quite dramatically. So in a way, those two dimensions are very predictive of reading skills at a given developmental point, where knowing the print-speech mapping is super important. Later on, there are going to be different patterns and different cues that are crucial for understanding this variability. Thank you.
Hi, I'm Karen, also from the Hebrew University. I was just wondering what you think the differences in an individual's tendency to be more sensitive to imageability or print speech regularity. Where does that come from? Is it like an innate difference in how they process information, or does it have to do with their education, the approach to learning how to read, quality of education? What leads to that?
Yeah, that's a wonderful question. So you're asking what are the sources of variability that we see in our dimensions, where we try to trace back reading skills too, essentially. So going even one step backward. That's, of course, a great question. The answer is that we still don't know. And most likely it is a combination of all of these factors. So both cognitive factors that can be thought of as almost innate, such as someone's ability to pick up on patterns and regularities overall in the environment, regardless of the domain, seems to have some role here. So we have those type of measures, and we see correlations between them and those dimensions, that is sensitivity to patterns in the specific domain of reading. But of course, also more social, experiential factors, such as what is the teaching curriculum that you got up until this point. How strong is your language system, regardless of reading? These are super important factors as well. So what we try to do is, in a way, I think that we should examine all of these factors together, just that now we have a more precise way of understanding how those social factors explain reading later on, essentially. Thank you.
Hi, Noam. Thank you so much for a very interesting presentation. I'm Ala. I'm also from Hebrew University, and I'm interested in the outcomes of this. So we speak about best readers. What does it mean? I mean, in a social context, does it mean that people are able to read more books, whatever sources, in a short period of time, or they are reading more efficiently? They remember better. How is it connected, maybe, to remembering what they read? I have a friend who reads literally one book a day. I mean,
yeah.
It's thank you.
Yeah, that's a wonderful question. So we're asking, what are the implications of those variabilities later on? Essentially, what does it mean that a person picks up on these patterns earlier on? I mean, of course, it's an empirical question. So, one day we are hoping, it goes back also to the last question, we are hoping to run those longitudinal studies where we actually start following kids from very, very early on, already from kindergarten, getting a lot of information about their environment before they started literacy acquisition. This goes back to the last question. And then we also want to follow up them. We want to follow them as they grow and grow and grow later in life. I would say that, of course, there's a vicious circle here in a way. You have to have those early reading skills in place to read more, to enjoy reading more. And then, of course, when you enjoy reading more, you get more and more high-quality input, which helps you pick up on more and more and more subtle patterns. And the idea is that this is something that is true in probably all cognitive aspects of development, but specifically in reading. This is why we have to have measures that are sensitive enough early on, because we need to intervene earlier. Otherwise, we are already into this vicious circle and we won't get out of it. Yeah. Thank you.
Hi, Jonathan Belinkov from the Technion. I have a question kind of related to a previous one, which is whether you're trying to make any causal statement. And I think there's a particular, maybe interesting data point. People who don't have the ability to hold mental images, so they have aphantasia. So would we predict that such people would be better readers?
That's a wonderful question. Yeah, so two questions essentially. One is about the causal mechanisms here. Do I have a causal statement? And the other one is about people who have specific problems actually imagining stuff. Do we actually have the counterintuitive prediction that are going to be better readers? Let me start from the second point. Of course, it's an empirical question and it's speculative, so apologies. I would say actually no. So I know that it sounds like it from the data that I've shown you here, but we have more data that actually shows that remember this farmer, trader, fighter example, but not corner, right? This is also something that has to do with meaning, right? And there are actually patterns there, and there are actually regularities there. And we have follow-up work that actually shows that readers who are sensitive to those type of very probabilistic, complex patterns in the mapping between print and meaning are actually good readers. So imageability is really this very particular type of cue that is arbitrary, that is not helpful, that doesn't have to do with your sensitivity to different patterns. So I think that not having any type of strong semantic representation of meaning can be detrimental to other aspects. The first question about causal patterns, causal claims, it's again a wonderful question that I think we are all we are all, I wouldn't say not sleeping at night, but we are all thinking about quite often. the only answer to this is, again, goes back to this idea of longitudinal studies. The only way that we can actually claim strong causality here if we start early and follow those kids to the longest time that we can. We are trying to do this. We are constantly going earlier and earlier and earlier in childhood. And who knows, perhaps in a couple of years I'll have some answers there.
Thank you very much, Noam. Excellent talk. Thank you.